Hello everyone, my name is Jaesung and I'm so excited to tell you about a new version of Sendbird UIKit and iOS, including a new dynamic way to customize UI with amazing wizards. My goal is to help you easily understand the changes of UIKit version 3. First, let me help you understand the architecture of Sendbird UIKit and what's new in version 3. Later, I talk about customization using the UI components provided by the UIKit. And finally, I will show you how to use UIKit 3 with extra customer requests. Alright, let's start with the architecture. In the overview of architecture section, I will introduce the overall architecture and role of each different part. Sendbird UIKit has a dependency on Chat SDK, which communicates with Sendbird server directly. An application uses UI elements provided by UIKit. Chat SDK manages chat data while communicating with the server. It sends events to UIKit when there are updates on the data. UIKit calls Chat SDK interfaces when the user interaction has occurred or other circumstances. When the Chat SDK sends events to UIKit, UIKit updates views with received updated data through the event. Therefore, it's possible to utilize chat features even if you do not know the Chat SDK interfaces. I'm going to show you how easy it is to use UIKit. Here's the code snippet for showing the list of group channels. The group channel list is the very first starting point of using basic UI and features in Sendbird UIKit. You can use all provided features via the channel list view that is displayed by the code. SBU Group Channel List ViewController is the name of the ViewController that shows the list of group channels. You can create an instance like this. The navigation bar is used in every ViewController provided by UIKit, so you can show the controller object by the push method of navigation controller. Surprisingly, there's no Chat SDK interface used in the whole process. Alright, now I'm going to show you what's new in Sendbird UIKit version 3. In version 2, the view controllers owned many view properties, and the higher the number of view properties, the more code was required when there were any changes to the properties. However, the way of organizing the views has changed from version 3. The view controller will now use modules consisting of views with the same purpose instead of using multiple view properties. Each module has more than one component, such as header, list, and so on. Each view controller has these components and configures the UI. In Sendbird UIKit, there is a module corresponding to the key function of each view controller. For example, SBU Group Channel List module corresponds to SBU Group Channel List View Controller, which shows the list of group channels. The View Controller conforms to the delegate and data source of the module component. From the delegate, it receives the view update events from the component. From the data source, it provides the data to the component that is required to update the views. Let's move on to the view model. According to the key function, each view controller has a corresponding view model. For example, SBU Group Channel List view model corresponds to SBU Group Channel List view controller. The view model manages the data required for the view while communicating with Chat SDK directly. View controllers can process chat related data through the view model without calling the Chat SDK interfaces directly. The view controller conforms to the delegate and data source of the view model. From the delegate, it receives the data update events from the view model. From the data source, it provides the view element values to the view model that is required. Through the view controller, the component and the view model interact with each other. The component and view model notify the updates to the view controller as an event. When the component and the view model request the view controller for the data that needs an update, the view controller delivers the data by using the data source. Because the component is a view element, this architecture corresponds to a MVC. Let's move on to the module set. To manage every module, Sendbird UIKit has a global class called SViewModuleSet. Each view controller accesses the module set and gets components from the modules as default while running the app. SViewModuleSet has several modules and each module has several components. To manage every view controller and resolve chaining issues, there's global class called SViewController Set. The ViewController Set has every view controller according to the key functions. The view controllers are used as a default while running the app. Let's move on to the Sendbird lifecycle. The Sendbird lifecycle is a common interface that works alongside Apple UIKit lifecycle. The SVU-based view controller is the UI view controller that conforms to Sendbird lifecycle. According to the Apple UIKit lifecycle, the view controller calls the below Sendbird lifecycle interfaces. Setup views sets the value of properties used to create views and sets the hierarchy of view components. Setup layouts sets the layout of components within a view. Setup actions sets the action of a view such as button. These interfaces are called when the load view method of Apple UIKit lifecycle is called. Setup styles sets the style of a view such as color, string, value, and font. This interface is called when the viewDidLayouts of views method of Apple UIKit lifecycle is called. SVU is a UI view that conforms to the Sendbird lifecycle. Events from Apple's UIKit lifecycle correspond to interfaces below from the Sendbird lifecycle. When Apple's UI view's lifecycle is initialized, setup view, setup layout, and setup actions will be called. And UI view's layouts of views will call setup styles. A module has an additional Sendbird lifecycle interface called configure. The module's UIKit lifecycle corresponds to Sendbird lifecycle interfaces as shown below. Configure will set necessary components for setting up the views such as delegate, data source, and theme, and call setup views, setup layouts, and setup styles. SVU view controllers setup styles are setup views which gets called from UI view controller's load view. It calls the configure method. Let's move on to the next section. Here you will discover various ways of customizing views with the new UIKit version. First, I'm going to tell you how to customize the view controller. ViewController Set has several view controllers types according to the key functions, and these view controllers are used as default during runtime. The first way to customize is to update the ViewController set. By overriding a provided view controller, you can create a new customized view controller and then update the corresponding value in the view controller set to the customized view controller. Now it's used as a default view controller for its key function. Here's the code snippet. I will show you the customization on the group channel. Create a class named Custom Channel View Controller. This class inherits from SBU Group Channel View Controller to show group channel messages. And then update SBU View Controller Set to use Custom Channel View Controller when it needs to show a group channel view. When you display the channel list view controller, you can find that it uses Custom Channel View Controller to show the group channels. Another way to customize it is to override the view controller provided by Sendbird UIKit, not override it from ViewController Set, and create the instance in specific scenarios instead. From the show channel method in SBU Group Channel List View Controller, you can create a custom channel view controller instance and display it on the screen. Let's move on to module customization. ModuleSet has several modules depending on the key function. Each module has several components such as header component, list component, and so on. These module components are contained by a view controller that has the same key function. The first way to customize a module is to update the module set. You can create a custom component by overriding a module component and update it on the module set to change the default component that is used across Sendbird UIKit. Here's the code snippet. I will show you the customization on the group channel. Create custom channel header class that inherits from SBU group channel modules header class. Next, update group channel modules header component from SBU module set with the custom header class that we created from above. Group channel module is a module that corresponds with SBU group channel view controller's key functions. After this is updated, the newly created group channel view controller's header component will use the custom component as default. The second way to customize a module is to update the module component in the view controller to the customized component. By overriding the module component, you can create a customized module component and use it to specific view controller instead of updating the module set. Here's the code snippet. We'll use the custom channel header we created earlier. You can also use the custom header to apply changes only to a single view controller by updating the header component value of group channel view controller. The third way to customize is to override the behavior between the view controller and module components. All module components use delegate patterns to deliver events from the view to the view controller and use data source to get necessary data for updating the view from the view controller. You can override this method to customize its behaviors. Here's the code snippet. Create a new view controller class called Custom Channel View Controller, which inherits from SBU Group Channel View Controller. Let's customize the header component of the group channel view controller. The base channel module did tap left item is a method of SBU group channel module header delegate. It's called when the left bar button of the header component is tapped. Let's override this method. From inside of method, you can update UI elements while accessing the header component object and the left item object. Let's move on to the customization of view models. The view controller creates a view model, and the created view model sends events to the view controller through the delegate and gets values of views from view controller through the data source. The first way to customize the view model is to override the delegate and data source method in the view controller. It allows you to handle the communication between the view model and the view controller. Here's the code snippet. Did change channel with context is a method of the view model delegate. This delegate method is called when there is an update on the group channel. Let's override it. From inside of the method, you can access the view model, channel, and message context object to update views. The second way to customize the view model is overriding the create view model functions in the view controller. Then you can customize the time when the events are invoked and the actions when the view controller receives events. Here's the code snippet. First, you need to create your own channel view model class, which inherits from SB group channel view model. Second, please create your own channel view controller class, which inherits from SB group channel view controller. Let's take a deeper look inside custom channel view controller. You have to override the create view model function to use your customized view model. This function is called from the initializer of the view controller. Before creating a view model object, please check whether the channel information is valid. Then create a view model object with given parameters. Don't forget to set up delegate and data source to receive events. We are now at the final section, implementation. In this section, we'll look at an actual request from a customer and customize the UI according to it. First, we'll look at a customer request from Versa. Then we'll decide how we'll organize the view hierarchy in order to customize the UI kit. Lastly, we'll look at the data flow and the customized UI kit. Versa wanted to use a typing indicator and delivery and read receipt features that were originally supported within a channel in the channel list as well. Now we'll start with the customization using SBU group channel list view controller, which shows the channel list. SBU group channel list view controller corresponds to the SBU group channel list module. Specifically, the list component is in charge of showing the channel list on the view controller. List component uses SBU base ChannelCell class to show each channel item. SBU base ChannelCell will be configured like this. On the right side of the channel name, there's an image view that represents delivery read received state. On the bottom of the channel name, there's a label to show typing indicators as well as the last message. Here's how the class structure will be like. The modules list component contains ChannelCell, and ChannelCell contains state image view and message label, which reflect the delivery read receipt state and typing indicator respectively. Now let's customize the channel. You can create a custom channel cell by inherits from the SView-based channel cell class. Here's the code snippet. First, create a class called versus channel cell and make it inherit from SView-based channel cell. Next, declare a variable called message label, which will be used to show the typing indicator. Then declare a variable called stateImageView, which will be used to show delivery read received states. Next, we'll also add properties which will help us organize layout between multiple SView step views. Content step view is a horizontal step view that contains all of the view properties that exist inside a channel cell. Label step view is a vertical step view that contains channel title and message label. Lastly, title step view is a horizontal step view that contains channel title and state image view. After all the view components are declared, we'll override the interfaces from the Sendbird lifecycle as we have seen in section 1. In case you forgot, configure channel is a method that redraws the view when a channel is updated. Let's set up views. By using setHStack and setVStack functions in SViewStackView, you can set up the views and their hierarchy. Let's set up the layout. Set the spacing of content stack view and the height of title step view and the size of state image view. After that, SViewStackView will set up layouts of other views automatically with its alignment and its spacing. And then let's set up the styles. You can access the theme from SView-based channel cell easily. The theme contains font and color. From the configure method, you can update channel cover image, channel title, message label, and state view. Create a method called updateMessageLabel, which checks if there are any users that are currently typing. If there are users that are currently typing, use the channel header typing value from SViewStringSet to update the message label's text. Then create a function called updateStateImageView. Using the last message that the current user sent in the channel, use SVUUtil's getReceivedState method to get the received state value. Use the received state value to get an appropriate icon from the Sendbird UI SVU icon set. Before we apply it to state image view, use the SViewWidthTintColor method to set the correct color and use ResizeWidth method to resize the icon to fit the state image view. Now, we'll create a custom module component in order to use the customized channel cell inside the list component. Create a new list class that inherits from SB group channel list modules list. After that, override the setup views and call the register function to use versus channel cell before setting view elements. Lastly, let's move on to the function that shows the list of channels. Update SView ModuleSet to use customized list component before showing the ViewController. After the update, Sendbird UIKit uses it as a default of the list component of the channel list module. Of course, you can make this simpler. You could just access the list component of the ViewController and call register function to use the customized channel cell without a customized list component. So in this way, customizing versus use case is complete. Now let's check out how ChannelCell is updated. First, when a change is made in the channel, the view module receives an event from the chat SDK and calls the view module's didChangeChannelList delegate method. When this delegate method is called, the list component is reloaded, and during this process, the ChannelCell's configure method resets the view along with the received state and type indicator. Here's the code snippet. When there's an update on the channel, the didChangeChannelList event of viewModule is called. In this delegate method, it invokes the reload table view in list component. Inside the list component, you can see that the reload table view method reloads the table view data. When the table view is reloaded, it calls the self-row event from the UI table view delegate. The event calls the configureCell method with the registered ChannelCell. The configureCell function calls the configure method and setupStyles method of the ChannelCell. With a real example from a customer, we have looked at how we can customize UIKit and how the customized views behave along with the data flows. Thank you for listening.